Good morning, everybody. Thank you for hanging out, I guess, to the Wednesday keynote. I appreciate the fact that our opening speaker said that while content is important, it's not everything, because when you have a mid-level government bureaucrat coming to do your keynote, there's no guarantee of content. I will do my best, I promise. So what I'm going to do for us this morning is I'm going to talk a little bit about the agency, about NIST, kind of introduce you to whom we are, talk a little bit about how we view technology and some of the research collaborations, especially in technology and security, that NIST is looking at for the future. And then if there's time, I'd be happy to listen to questions and potentially maybe even answer them. So that's what I'm going to kind of run down here today. So here's NIST's mission. No one really kind of runs a lot by mission, but we do have some core values that we work on NIST at the U.S. National Institute of Standards and Technology. Integrity, inclusivity, excellence, and perseverance. It's not uncommon for folks at NIST to work on a very hard problem for a decade or two. And it is through that type of perseverance and integrity and excellence that allows NIST to have things like 5 Nobel laureates working on campus. Their research, which awarded the prize, being done at NIST campus, and things like semiconductors, quantum engineering, crystalline structures in chemistry, that type of work. So it's a wide variety of research. It's a big portfolio. Within the Information Technology Lab, we're all about cultivating trust. And so we're going to talk a lot about trust and trust roots. So who is this weird agency that I speak of? We're actually part of the U.S. Department of Commerce. As called out in the Constitution in Section 8, the government fixes weights and measures for the nation. Established in 1901, we're the oldest national lab in the country. At that time in 1901, as weird as this sounds, there were 8 different authoritative, in quotation marks, values for a gallon. So we have trust roots. We do trust extensions inherently all the time, that when you buy a gallon, you get a gallon. In the 1900s, that was not the case. If you wanted to know how long a foot or a meter was, you had to send your instrument to Europe to get it checked and calibrated, and then put it on a boat and get it back to the United States. This was untenable for commerce, and so the National Bureau of Standards was set up to deal with this very issue. Lots of standards jokes. I will not bore you with them. We're a special kind of people who enjoy standards. There might be one or two of you out there as well. We can have a coffee later. We're located in 2 main areas: Gaithersburg, Maryland, which is where I am from and where the Information Technology Laboratory is mostly hosted, and then Boulder, Colorado. Boulder is probably most known for, and you may have heard of, the clock. And that's all you have to say, and most people know what that is. So the atomic clock is out in Boulder. So how we work at NIST is very similar to the theme of the conference. Inclusivity, working together to address the challenges of tomorrow. We are, by a state of comparative metrology with other federal agencies, small, okay? Roughly 3,000 researchers, roughly another 3,000 guest researchers who join us, relatively small budget. We are also non-regulatory. So through those different mechanisms, being non-regulatory and being small, we collaborate extensively with industry, with academia, with other governments, in order to ensure that NIST's work is as correct and applicable as possible, and honestly to leverage your experience and to leverage your knowledge, because that helps us extend our capabilities as well. All right. Trust extensions is what I'm going to talk about. NIST is the keeper of what we call the SIs. You probably are, well, maybe you are aware of these, maybe you're not. These are the units internationale against which all measurement is founded. The kilogram, the mole, the second, the ampere, the Kelvin, the candela. These are physical properties for which you extend trust. Again, that gallon is a gallon. You know, A second is a second. The time is the time. And it's universal, everywhere, for everyone. If you have an instrument that does a physical measurement, it has a probable calibration to it. The calibration source for that laboratory that calibrated your device traces itself back to either that Gaithersburg or that Boulder campus, where these fundamental units of measure are kept, so that you can have a trust extension when you go to a pump and pump a gallon. You don't have to worry about it. You know, you don't even have to know that you're getting a gallon because it is a gallon. And we deliver this through all these different things, mostly those standard reference data. But then how do we do this for security? Is there an SI for security? What is that fundamental trust unit that we can base our work on in order to ensure that our higher level items in the stack are true, accurate, and are correctly represented? There is none right now. It's the race to metal to some extent. Mike Bartok back there, one of my colleagues, likes to joke, you play the 7 degrees of separation from Kevin Bacon, right? If we could just secure Kevin Bacon, we would have a trust root for which we could leverage everything else from. But Kevin Bacon is an inadequate trust root, so therefore, what are some of the ones that we can use? I hit my clicker, there we go. So these are some of the things that NIST is looking at to try to establish some trust roots, working collaboratively with industry and academia. The strongest one that we work on is in the areas of cryptography. NIST has a long and strong and a bit storied history in encryption and cryptographic technologies. We keep and maintain the US portfolio for encryption, the block ciphers in AES and in 3-key triple DES. And if you're using 3-key triple DES, please think about moving off it. For asynchronous cryptography in RSA and in DSA. And if you're using DSA, please keep an eye on that as well, because we're going to think about starting to deprecate DSA and elliptic curve DSA as well, moving forward into the future. And we're building next sets of encryption that will enable us to stay strong and have some kind of foundational trust in the advent of what a quantum computer will be able to do in factorization of our current asynchronous cryptography. So it's not just current and maintained. We also run a check and validation program, but also looking at the future of encryption and cryptographic technologies. I'm not going to run through all of these. I like to plug crypto because it is one of those core things. We work at a high level, everything in philosophical issues of risk management, looking at things like the cybersecurity framework, which was built with industry to how to discuss and communicate security properties, all the way down to specific vulnerability metrics, a common vulnerability enumeration with a score. This vulnerability is an 8. Run to your server room. This vulnerability is a 2. Do it on Tuesday, type of things. And then we put out lots of papers, standards, and guidance, and I apologize for that. Our modus operandi is to give you a PDF. Now, being a kind of a quasi-research organization, that's how we incentivize our folks inside. So it's about papers, it's about publishing, it's about journals and articles, it's about work in standards. So often our default way to communicate and to express the results of our research is through a paper. I was having a conversation this morning, though. As we all know, papers are nice, but the thing that speaks loudest is running code. Tools, technologies, software, things that people can pick up and actually implement or understand their implementations. So as we continue to drown you in voluminous PDFs, we will also be continuing and shifting more to use of tools, testing, input vectors, and data references to help you with your specific mission, and then also to provide a little more reality to some of those PDFs that we like to ensure that everyone gets lots and lots of. Some of these things you'll see at the bottom there that we're continuing to actually develop and move out on is to look at things like a public-sourced randomness beacon. and providing these types of trust root services to the public that then they potentially can pick up and run and use. It is not a blockchain. I want to make sure that's clear. You will not see the word blockchain in my presentation. So as we look at technology moving forward for the future, where are we? We kind of look at it in a couple of different perspectives. To some extent, we might be in a little bit of a lull, okay? Things seem to be kind of stable. Standards are deployed. Technology is kind of everywhere, and now we're just running Moore's law to squeeze more and more out of what we got. So, this is my favorite kind of thing I like to think about where I am. I have 7 years to retirement, till I hit my magic government 30. If I can sit on my beach in my current state and ride it out for 7 years, wouldn't that be nice? But are we here, or are we really here? And I apologize for the hurricane reference. I did my slides a week and a half ago, and I didn't realize we actually might be here. That's a different issue. Are we potentially, though, in the eye of a storm? Are we at the doorstep of some significant technology disruptions in the next 5 to 15 years, well within my retirement timeline, that is going to cause significant changes to how we look at technology, how we access, own, curate data, where our technologies are deployed, and how we think about the trust in these technologies going forward. And we've seen a lot of this recently in some of the uses and applications in both data, technology, platforms, and calling to question both how we're using them as a society at the policy stack, but also how they're being used and how the original intent was deployed versus how they're being leveraged. And so these are things I think that all of us are going to start to have to kind of wrestle with as these technology disruptions give us another opportunity to look at our architectures, our implementations, our platforms going forward in the future. All right. So here's my acronym list, and I apologize for this, but I'll go through some of these. Hopefully you know as many of these as I do. So what is NIST looking at as far as these disruptive technologies going forward? This is, in a nutshell, our R&D portfolio in both IT and cybersecurity looking in the future. I got IoT at the top of the list there, right? But it's not just IoT. We're looking at IoT from a perspective of divergence of the platform. So we all got one of these, right? Half of us are on them right now. This is our access point, right? This is how we interface right now through this. Historically, we've seen a convergence to this. IoT is an example of now we're starting to diverge off this platform. We're going to have different mechanisms for interfacing with our technology, with our architectures, with our data, with the generation of data. And IoT is the prime example of the divergence of the platform. So it's not just sensors in IoT going out there. And then it's going to be, what currently is, clothing, glasses, footwear, vehicles. Everything we use in our everyday life now is going to become part of the mechanism that we use to interface with our digital life as we diverge off the phone. The phone may still be the concentrator or the gateway, but it's going to be no longer the primary interface. And part of that will be an enablement of the next line there, which is both artificial reality and augmented reality and virtual reality. So bringing that digital presence potentially into our lives through augmentation. And this is already, again, already happening, all right? Earbuds, which then are also going to read us direction off of Waze directly as we go, potentially tell us my buddy's in Starbucks and there's a sale going on at Home Depot down the street, or just coming straight in through my Google Glass, which is going to lay out my course. This type of augmented and enhanced reality through our digital interface as we diverge off our platform, being enhanced through voice. Voice is, again, one of these historic things that we're seeing where we look at it as the future abstraction of the interface. I'm looking through the crowd. There might be a couple of people here who did punch cards. I did not do punch cards. You do a punch card, sir? You used to do punch? I'm sorry, I didn't mean to call you out. Who did punch cards? Yeah, okay, I didn't do punch cards, all right. Who did? This is a good audience for this question. How about assembler? Oh, I'm sorry, I did not have that. I did do C, but not assembler, okay. You all remember, right, you were down in the interface, right? You were close to it. You were ring 0, ring 1. You were highly privileged. This made the ability to interact with the digital world a specialized environment. Only very few people could do this. Over time, through punch cards, assembler, C, Java, GUI, icons, voice, the abstraction of the interface to make it easier and more accessible to the digital environment is a trend that is rapidly accelerating, and voice is the culmination of it. I'm interfacing with you by talking. The goal is to get that Turing test objective, right? So that the interface with the machine will be voice as well. So Alexa and Siri and Cortana, these are all just betas to build this out. And whoever gets that right the first time is going to be a nice thing. And then underneath that, of course, is the machine learning and artificial intelligence capabilities that's going to enable voice for those natural language processors to allow that interface to happen, to bring in that augmented reality through this diversion on the platforms. We are generating data like crazy. So there's data markets happening behind us. This used to be a big secret. It's not as much of a secret anymore. These large data markets that are happening, and the shift from data curation and looking at presenting information to you curated to your habits, to presenting data to you to adjust your habits. So there's this shift occurring now where folks who are control and own and are running these data markets don't want to just serve you, but they want to have you be more targeted to them. This will be an interesting aspect as we go forward. For example, why are all Starbucks a Pokestop? Anyone ever think about that? My kid does, because they want to get you into Starbucks, right? And while I'm here at a Pokestop, I'll get a coffee, okay? So it's about behavioral analytics now. How can we look at and adjust folks' behavior? And we've seen this at scale in certain platforms performing societal experiments on behavior and thoughts. So as we generate this data, as we use this data, as we curate this data, we all should be looking at who owns it, where's it going, what are the power structures in there, how are the EULAs formed and for whom and for what purpose, and are there things that can be done or should be done as we look at reformulating how we decide about the privacy of the information that we generate. This is going to be an interesting topic going forward, as at least for NIST, when we look at things like privacy engineering, privacy frameworks, the ability to express privacy capabilities in an understandable manner between systems and amongst each other. This is going to be an interesting research area for us. High performance computing, next generation HPCs, again, link back to AI and voice. I am not an expert in HPC. We have other people at NIST who are really working at this. But we're also very interested in how our technology is driving our high-performance compute capabilities. Do we need high-end processor, lots of NAND gates for AI versus big pipes and movement capabilities for machine learning? And are those two platforms diverging, or can they converge? And will we force a separation? We don't know. These are interesting research areas for us. Everything as a service. It used to be a software platform, right? Now it's everything. Amazon now offers, and this is really cool, you can have a satellite as a service. So What you can do is you can go to a flat rack satellite company, spec out a sensor satellite for a couple of grand, have it hitch a ride on a Tesla Falcon for another couple of grand, put it up into low Earth orbit, drop a credit card with Amazon. Amazon will give you satellite ground station as a service. So you can control that satellite, download your data, dump it right into an AWS instance. A couple of months later, you lose orbit and burn in, and you've got your data right there. It's kind of fascinating. But these are the types of services now that you can get, that you can offer, and that people are getting for you. I touched a little bit on quantum-resistant cryptography, QRC. I want to touch on this a little bit more. I asked the physicists at NIST who are working on quantum computers and quantum infrastructure, when is Q-Day? And for me, Q-Day is not the 3 qubits that we currently can control now. But Q-Day is what I call a quantum relevant machine, a cryptographic relevant machine. A machine that will have enough controllable qubits in order to implement Shor's algorithm and basically defeat RSA encryption. And for the last 5 years, every year they tell me 10 years. So I asked again, and they said 10 years, 10 years, 10 years. So some of the best physicists at NIST still have not been able to accurately, at least they won't put themselves on paper, predict when a cryptographically relevant quantum computer is going to be around. But when it does, and it is really a matter of time because we've gone from theoretical to engineering in this aspect, RSA will no longer be effective. Diffie-Hellman key exchanges also will no longer be effective. So we are working now with the international community in identifying and eventually standardizing replacements for our asynchronous cryptography and for our ability to move keys around securely. We anticipate having those standards ready in the next 2 to 4 years. And then what we'll need from you, once those standards are done, is to find out where you're using that cryptography that's now vulnerable, prioritize the data that it's protecting, what's the most important stuff there, and then start working on your migrations. If we've learned anything, and it's at NIST, especially around cryptographic transitions, is that once these items get into our legacy systems, transition is a decades prospect. How many of us are still using single key DES? Keep your hands down. How many of you are still using MD5 hashes? Keep your hands down. Okay? We know it's not, oh, wait a minute. How many of you are still using SHA-1? I'll keep my hand down. But the government is, even though NIST has said stop. These are difficult things. Legacy transition from cryptographic algorithms is a long process. So the lessons we've learned is we need to start preparing so we understand where those cryptographic technologies are, what they're protecting, and then start to prioritize. So if you're still using RSA or elliptic curve Diffie-Hellman 15 years from now, at least you're not going to be using it on something that's critical. Use it on something that's not so important, and prioritize those transitions as they come. I apologize, but I'm going to say 5G. Now, when I say 5G, I'm actually going to talk about the technology, not everything else around 5G issues. I'm not going to talk around supply chain or trade or any of the other issues. I'm talking about technology. One of the things that's going to be incredibly important to standardize and to bring about all of those things above us in this stack of crazy items I talked about is the ability to connect them. Most of the barriers in order to achieving not just these as an individual item, but really what's going to happen with all of these technologies that are going to be so disruptive is when they start to combine. When you put HPC, high performance computing, together with voice, augmented reality, distributed sensor systems, everything as a service. Once we combine these individual stovepipes, that's when we believe significant change is going to occur. but the ability to combine them is dependent on our pipe. So we've got all these muscles. What we need is a good vascular system in order to ensure that we can leverage the combinatorial effects that these individually will bring us. And we think 5G connectivity will be that connective tissue that will allow the combinatorial items of these individually to cause this type of disruption as we go forward. So we're very excited about 5G. We think actually the 5G technology is going to be more secure than our current LTE 3GPP technologies, just because of the current standard service offerings it has natively as well as optionally. But we're most excited about the connectivity and the pipes it's going to bring us that stitches all these together. And at the bottom there, I got that. Again, there's my plug again for quantum. Whoop, I hit the wrong button. I hit the laser button. Sorry. Anybody okay? All right. There you go. All right. I'm pretty sure it's iSafe. All right. So again, we're not quite sure exactly where we are. Are we in the eye of the storm? Are we good in our current situation going forward? Are we in the lull? Or is that storm on the horizon coming to us? We've got this wrong before. NIST has got this wrong before. We did a whole set of documentary standards on WiMAX. We got that wrong, okay? I still have my beta player and my laser disc player at home. Sometimes we get it. Yeah, you're nodding your head, sir. You got one too, yeah. I got Star Trek 4 on laser disc. Yeah, that was a wise investment. Sometimes we get it wrong. But sometimes it's too important not to ensure that we don't bet on one. So this is very applicable to the theme, addressing the R&D challenges and security together, okay? So how do we stay relevant? How does NIST stay relevant? How do we attempt to stay relevant in this dynamic, in this changing area, be it a lull or be it a storm in the future? It's not just documentary efforts. It's got to be applied cybersecurity, applied technology as well. We mentioned the National Cybersecurity Center of Excellence. This is an applied engineering facility we have in Gaithersburg, where we take those documentary standards, we work in a cooperative research and development agreement with industry and with academia, and we actually do architectural implementations and builds. We will build out what security in a hospital environment for IoT looks like. How do you secure infusion pumps in these specific contexts, for example? We will build out how to fingerprint using IETF protocols devices, maintain those fingerprints and constrain your environments. We will build out how to implement cloud architectures. So if you need to constrain or migrate or secure a workload or a data set or a process, you can do so. And then rather than just a PDF, the team out there at the CCOE will work side by side with industry, with academia, and develop running code for examples for people to pick up, to understand, and to use. And this gives us a bigger picture, again, of those legacy issues. What am I building in? What am I taking out? Total cost of ownership and overhead as well. It answers a lot of questions that we don't get just in generating the PDF. We work extensively with international partners, and we do this through a couple of different venues. I'm going to come back to the S in NIST, which is standards, be it the IETF. Can I drop standards acronyms? I tried not to be acronym heavy. I'm from the government. We love acronyms, usually ones that no one else knows. So be it with ISO, the International Organization for Standards, the Internet Engineering Task Force, or any of these others, standard setting, standard development organizations. That's usually our main way to work with industry in standards bodies. In the US, industry leads in standards participation. Government supports you, industry, in standards bodies. You've got markets, you've got customers, you've got investments. You need to ensure they're viable not just for the US but globally, and that's done through standards bodies, and we are supporting you there. We also work with our like-minded countries in the reflective agencies from NIST. So in cryptographic standards, it's lovely for the US to have a cryptographic library. It's more important that the EU accepts it, Japan accepts it, Australia accepts it, Korea accepts it as well. Because in the end, we're all using commercial products. So I want the first implementation in the stack to be AES and SHA. And I need that to be globally accepted. Okay? Industry has a choice. It's best if we don't give them bad ones when we look at markets. And then, of course, working in research and development and all of those other areas that I talked about. I spoke fast because I'm from New York and I'm a bit over-caffeinated. But I'd be happy to take any questions, comments, musings, thoughts that anyone might have. Okay? Yeah.
I have a question.
Oh.
Where are you going?
I'm not going anywhere.
So you mentioned lots of topics there.
I did.
Yeah, they actually align very well with our interests and etc. So what kind of roles do you think industry can play to help NIST? I mean, we have ARM is very pervasive. We have a strong ecosystem. So what kind of roles industries such as could come and basically interplay with you, no matter from the standard standpoint, but also the root level?
Yeah, no, that's an excellent question. The government does not take enough advantage of the capabilities that things like ARM has for security in our current platforms. So a lot of what we would ask of ARM and of industry is to ensure that we fully understand the capabilities that you offer and that we are taking advantage of it. What happens often in the government, and this may be a shock to a lot of people, is a capability gets put into a procurement spec. It gets purchased because it's in the procurement spec, but it never gets enabled. And, so switching on, enabling, and use of the native security capabilities, especially in these trust root arenas around provisioning, establishment, and then signatures up the stack, for example, are critically important to ensure that the government maintains the security postures that we need, because we've got a really unique threat model in the government. So working close with NIST, with NSF, with DoD, with DHS, so that we understand what we should be taking advantage of and what we should be leveraging.
Okay, we have a charge, I guess.
Yes.
Are you charging us?
There's a, yes, sir.
Yeah, so my question is about autonomous driving. Do you think that there's going to be a lot of standardization around that? And what are some of the activities your organization is doing to ensure safety and regulation?
In driving, did you say?
Autonomous
yeah, in automotive,
driving.
yeah. Okay. Excuse me, I'm reloading. Automotive safety and security standards are being led by the National Highway Transportation Safety Agency. We call them NHTSA. They're part of the US Department of Transportation. NHTSA is working directly with NIST as well as with standards bodies in looking at two issues around this, safety and security as an aspect of safety. And so we, NIST, participate in the SAE standards body. And SAE has published a gradient of security, automotive automation from 0 to 5, I think are the levels, 5 being fully automated, and then different levels in between. We're all driving in some kind of automated technology, be it ABS systems, adaptive cruise control, all the way up to fully autonomous transportation. NHTSA is working directly with NIST in the security aspects of it, but they have the safety responsibility. I'm not a safety engineer and I'm not a vehicle safety engineer, but I will tell you what I've heard them say, which is people are much more dangerous than the automated vehicles. And I'm not sure exactly what the numbers are, but roughly a couple of tens of thousands of Americans will die on the road today to preventable vehicle accidents that basically were human error. And NHTSA believes that that number could be dramatically reduced through automation. So there's strong belief that one of those, maybe not fully automated, but somewhere in that 0 through 5 stack, significant safety measures can occur. We've been working with NHTSA and SAE on things like PKI infrastructures. Again, things that are very relevant here. Security of bus transmissions, bus isolation, lightweighting type of things. So long answer for saying, generally NHTSA's responsibility. NIST is working directly with NHTSA on the cybersecurity aspects of it, and also within SAE and the standards body for it.
Thank you.
Yeah.
Hi, Brian Klein from ARM Research.
Hi, Brian.
I think you mentioned privacy a couple times.
I did.
I didn't see it come out prominently. I was wondering how security, privacy, what NIST is thinking about issues around privacy specifically, and if there are any differences between the general security, cybersecurity goals and work that you guys are doing.
Yeah. So yes, there are differences. You're really going to take me out of my wheelhouse here. The big overlap, of course, is in the area of confidentiality as an objective that spans both security and privacy. There are privacy objectives that are not necessarily security objectives around what is generally considered to be like data harms. So I can have complete authorization to access data, but there still might be privacy issues in my access of that data. So there's things around ownership, control, embarrassment, discrimination, bias that are not necessarily security objectives, but are definitely privacy objectives. I'm not a privacy engineer or expert. Naomi Lefkowitz at NIST, who is leading a privacy framework and privacy engineering program. And because we're NIST, we have a PDF that talks about both the overlapping and the differences between privacy objectives and security objectives. So I can get you that document so you can take a look at it. But
yeah, that'd be very interesting.
Okay.
I was wondering if there were standards and things around. Can you do a standard around privacy or things like that?
There are standards around privacy, believe it or not. There's an ISO standard. There's an ISO working group that's looking at privacy standards that we participate in. This is an international working group. And there's many other countries also that are looking at and working on this at a national level as well. There's been in the news recently also some folks in the tech industry who have said, look, we do need some kind of universal look at this because states are standing up. California, Michigan, and one other state, I believe, has passed some privacy requirements and some privacy legislation at the state level. So there is some concern about a bit of a patchwork versus a federal approach, and we'll have to see how that plays out.
All right, thank you.
Yeah, sure.
Hi, Reza Azer Dirak, Florida Atlantic University.
Hey.
Thanks for a great talk. There was in Boston a quantum technology conference. A speaker from NSA mentioned that NSA is also developing their own quantum resistant cryptography.
Correct.
I would like to know, are they working with you, or is NIST working with other entities in the country? And also, how do you see this from other countries? For example, other countries also developing quantum resistance algorithms. So could you comment on that?
Yeah.
Thank you.
Yeah. So a lot of questions there. So first, NSA has their own encryption technologies that is used by the US government to protect data that's classified above a top secret level. And these algorithms and these encryption technologies are also classified. NIST is a non-national security agency. We do not do classified work. So we do not see or know the Suite A, is what they're called, those highly classified algorithms, what they are. NIST's algorithms are accepted and used by the NSA and by the intelligence community in the United States to protect up to top secret. So commercially available, open source algorithms. So our quantum resistant encryption will be used by the NSA and by the US government to protect up to top secret. The NSA is working with us in that development of those, what we call Suite B, those public algorithms, not just the NSA. We have, as you mentioned, many other countries working with us as well. The UK, Japan, Korea, Australia, most of the EU, some of the South American countries as well. If you look at our post-quantum program, we receive submissions from 26 independent countries, 6 of the 7 continents. Slackers in Antarctica didn't submit. And so it's a very global community working with us in both the cryptanalysis of the submissions, and right now we have 26 submissions, 26 independent algorithms that we're evaluating, as well as the performance characteristics. So again, when we look at things like how do these algorithms work in hardware? How many gates are they going to take? What's their power consumption? These are things that we're very interested in as we look at these. So the international community writ large is both working with us, supporting us in cryptanalysis and evaluation of those algorithms, and is also committed to, when we go to standardize them, to backing us and coming in and saying, we're going to use those as well. So the UK, Germany, Denmark, Japan, Korea, Australia have all said, we're not only going to work with you in the cryptanalysis, but when the standardization occurs, there'll be our standards as well. Does that answer your question, sir?
Sounds good. Thank you very much.
Certainly. Thank you.
Thank you.